Alright, so we're going to look at the set notation questions from the January 2020 paper, and then we'll look at some others from previous years. So this one is one that recurs quite a bit, but in different forms, and I'll show you the different forms after. If the number of elements in a set A, that's what this notation means, N means the amount or number of elements in A, is M, then they want the number of subsets, which is just how much different combinations you can make at that set, and it has a formula. It's always 2 to how much items in the set, so the answer is going to be A. Now you wouldn't see it well with this one, so we're going to look at a couple from previous years. So we have, if Q is equal to the items A, B, and C, how many subsets can be obtained from the set Q? So again, if we were to write it like the last one, the amount of elements in Q would be 1, 2, 3 elements. So that is similar to how they write it here. They just use M. But this is what it will mean in that sense. So to show you how it will work, the answer is going to be 2 to the 3, by the way, following that same format from the last one. But let me just see why it's going to be 2 to the 3, which means 2 times 2 times 2, 2 2 4, 4 2 is 8. Think of it this way. We're going to have 3 people come to school, and Betty and Carleen. And we want to look at different combinations of these 3 students coming to school. So on one day, all 3 of them could come. So that's one possibility. But on our next day, Anna and Betty alone could come, Carleen stay home. On our next day, Anna and Carleen could come, Betty stay home. And on the next day, Betty and Carleen could come and stay home. But we also have Anne could come a day and the other 2 stay home. Betty could come a day, the other 2 stay home. Carleen could come a day, the other stay home. And we could have a day when none of them come, and this is the notation for the empty set. And as you could see, from a set with 3 elements in it, we could have 1, 2, 3, 4, 5, 6, 7, 8 different combinations. And that's the same thing the next one asking. Is just a different way they're asking for a different question. We set A is 3, 6, 9. How many different subsets we could have? So we have 3. So again, there'll be 2 to the 3. 2 2 is 4. 4 2 is 8. So the answer's still going to work out to 8. But you realize one asks for 2 cubed. The next one was 8. And one used a different number altogether. Well, use a symbol, M. Right? Next one, number 8. Which of the following statements describe the set of integers greater than -3 but less than 6? They bring a lot of these with the inequality signs. So starting off with x, if you notice, again, this is x such that x going to be in between 2 numbers. So x in the middle, but x greater than -3, not greater than or equal to, so that's the greater than sign. So x is greater than -3, but x going to be less than 6, not less than or equal to 6. So we're looking at one with that notation there, and the answer going to be D. We'll come back to some extra examples with those in a little while. Which of the following pairs, number 9 now, which of the following pairs of sets is an example of disjoint sets? Disjoint sets just mean they're empty, they have nothing in common. So they have no items in common. So even numbers and odd numbers, so let me start 2, 4, 6, 8, 10, and so on. 1, 3, 5, 7, 9, and so on. So obviously even numbers and odd numbers have nothing in common. My answer is A, but let's see why the others can work. Multiples of 2, I'm just going to write down. So again, multiples of 2 means your multiplication tables for 2. And I'll go on forever. Multiples of 3 is your 3 times table. And immediately we could see they're not going to be disjoint because they already have 6, 12. In fact, the lowest common multiple will be 6, so they will have factors of 6 in common. Sorry, multiples of 6 in common. Same thing here. Multiples are 5, 5, 10, 15. Factors are 21, 2, 4, 5, 10, 20. We could already see they have stuff in common. 5, 10, 20. So that can work. Whole numbers. So your whole numbers are just your whole numbers. Go on forever. And rational numbers, anything you could write as a fraction. So 2/3 is a rational number, but also 10 over 2, 5 over 1. So obviously these are going to overlap and have stuff in common. So the answer again, disjoint, have nothing in common. That's what it's going to look like. One with numbers now. So we have given A equal 1, 3, 6, 8, 9, 12, 15, and B equals 6, 9, 12. And they want to know, if you know your notation, which of the following statements is true. So just looking at the sets, we could see A and B have 6 in common, 9 in common, and 12 in common, meaning everything in B in common at A. And we call this situation a subset, where one set is basically contained inside the next set. So if we had set A and set B, inside set B we're going to have 6, 9, and 12, And inside set A, we're supposed to have 1, 3, 6, 8, 9, 12, 15. Well, 1, 3, 6 already inside circle A. 8, 9 already inside circle A. 12 already inside circle A. So it's just the 15. So that's what it would look like if I was to draw this set. So this is the situation where B, everything in B is contained in A, and this is the symbol for subset. So in sets, you really have a few main notations. We have intersection, which means they have stuff in common. Union, which is a combination of the two sets. Complement, which is the little one, which means everything outside that set. And then we turn the same notation on the side to call it a subset. So those are some of the main notations you're going to come across, and we'll see these in some other questions, but this one was with the subset, and they bring in the subsets a little more often now. Let's go back to some from different years now, similar to what we just looked at. So in this one, we have P is equal to 2, 3, 5, 6, Q is equal to 2, 3, 4, and they want P union Q. So I want to combine everything in both sets. So I want to combine everything in P and everything in Q. So I'm going to write down what I have in P first of all. So P union Q is a set, so that's why I use my curly brackets. So P have 2, 3, 5, and 6, and now I want to join Q to it. Q have 2, 3, 4, but I already have 2 here, so I'm not going to repeat it. I already have 3 here, so I'm not going to repeat it. So the only new thing I could add is 4, because 2 and 3 are already there. It's the same 2 and 3 they're talking about. Or I could write it in ascending order if I like. I don't have to, but for the purposes of this question, you'll see it a little better. That's what P union Q is going to look like, but they didn't want it as this. They get me again using the inequality notation here. So x such that x is less than or equal to 1, greater than 7. We want to see what each of these mean. So when it have a equal to piece, that means you include this number. So that means we include in 1, and we're going all the way up to 6, because they realized it didn't have the extra equal line here. So we're not including 7. So this included 1 to 6, which doesn't look like that. So we can't use that one. X is between 1 and 7. We're not including 1 and 7 because we realize it don't have that extra equal line. The extra equal line means we're including this digit, which we're not. So it'll be 2, 3, 4, 5, 6. Again, we're not including 7. So again, that's going to be my answer. But let me go through the rest and see what it's going to look like. X is less than or equal to 2. Is between 2 and 6. Less than or equal to 2, but less than 6. Sorry, greater than or equal to 2, but less than 6. So we include in the 2, 3, 4, 5, but this time we're not including the 6 because it didn't have the equal line on it. And the last one, x is greater than 2 but less than 6. Again, none of them equal, so we're not including the two end numbers, so it'll be 3, 4, 5. Another way to bring this type of question as a different topic, when they have a less than or equal to sign, they will use a solid dot on the number line, and when they have just a less than sign, they'll use an open dot. So once it have no extra equal line on it, which is the extra dash there, it will be an open circle. But if they have an extra line on it, it will be a closed circle. And hopefully we will see one of those questions later on when we're looking at that. Next one here, same idea. You realize this coming up often. X is a member of the real numbers, and they're going from -2 to 4, inclusive of both numbers. So that means it's going to be -2 because of the equal sign, all the way up to 4, -1, 0, 1, 2, 3, and we're including 4 as well because it have that extra line. So my answer going to be D. Let's see some more. Some more where they give you the technical thing, no real numbers, they're just going through what the numbers mean. So prime numbers are numbers that have 2 factors, and the 2 factors must be the number in itself, and it must have only 2 factors. So 1 is not a prime number. Your first prime number going to be 2, 1 and 2, 1 and 3, 1 and 5, 1 and 7. 9 have 3 as a factor, so that can be a number. 11, 13, 17, 19. We're going to go through those before. Those are just some of your prime numbers. Odd numbers, anything that's not divisible by 2, when you divide it by 2, you're going to get a remainder. And even numbers divisible by 2. And so on. And they want to know which one of these sets going to be empty, meaning when we intersect it, it's not going to have anything similar to this one here. Which one going to be disjoint then? So P intersect R. Do prime numbers and even numbers have anything in common? Yes, both of them have 2 in common. So this is not my answer. I can't union anything. Union means I'm combining all of this, so that'll be a really huge set. So that can't be my answer either. P intersect Q. Well, odd numbers and prime numbers have a lot of numbers in common, you notice. So that can be the answer. So the answer has to be D, but let's see why. Q intersect R, and come down to the same one like that one. Odd numbers and even numbers. Odd numbers and even numbers, Q and R. So my answer for this one would have been Q intersect R. Next one. Set M is PQR. Set N is just P and Q. Which of the following statements is true? So you realize again, this is a situation with a subset because P and Q already contained. So basically N, if I was to draw this diagram again, I have P, Q, and R inside M, but also have N, and N going to contain the P and Q, so the R just going to be outside. So M is a subset of N? No, it's the reverse. N is a subset of M. So this one out. M union N going to be N. M union N means we're going to combine these two sets, PQ and R, and we add PQ. Really, PQ already going to be PQR. So it's not going to be N, it's really going to be M. So this one, not correct as well. M intersect N empty. Well, if we're going to intersect it, both of them have P and Q in common, so the answer have to be D, but let's see why again. M intersect N is N. So if we intersect both of these, what both of these sets have in common? Both of these sets have P and Q in common, which is the same thing as what set N had. That's why the answer is here. Next one. If P and Q are two sets where the number of elements in P union Q is 13 and the number of elements in P intersect Q is 6 and NP is 9, they want the answer for NQ. So these questions, a diagram is very helpful. So in this diagram, we have an intersection of P and Q. And in the intersection, N, it have 6 items, so we put any 6 inside here. Use a different color. Let's see, it's all better. And the number in P alone is 9, so we have 9 items in this circle. That's what NP means. We want the amount in Q. The element NP union Q, meaning this whole thing here, all of these 3 pieces have to total 13 as well. So that's the information they give me. I just put it in a diagram. If this whole set have to add up to 9, and we already have 6 people in the set, here going to be 9 take away 6, which is 3. And now we know these 3 pieces have to add up to 13. So 3 plus 6 plus some number here is supposed to give me 13. So 6 add 3, I have 9 plus, we will call the unknown number x is 13. 9 plus how much going to give me 13? 9 at 4 is 13, or I carry across the 9, x is 13 take away 9. We still get the 4, so we find out inside here is 4. Now they're asking for the amount of elements in Q. Now Q means the whole circle Q, just like this was the whole circle for P. So in the whole circle Q, we have 6 people already in the center, but they still belong to Q, plus these 4 people, so my answer would have been 10, and we will look at the others in a little while.